Ladies and gentlemen, welcome back in our main hall. I hope you had the opportunity to take a closer look on this beautiful proving ground, automotive proving ground. In a way, this is the brain of the Hungarian automotive industry in terms of innovation and technology. And now, let me introduce you our next topic, which is the hydrogen value chain, ladies and gentlemen. Nowadays, having an idea, having a patent, having a new product is simply not enough. We have to think about the bigger picture, and our keynote speakers put everything into the bigger context, which is great. And where our idea, where our product fits in, this is the big question. This is especially true if our product is a new one and an expensive one, and we are working on making it cheap, making it available, making it popular. So hydrogen is the freedom element, and talking about value chains and the value chain of hydrogen is not something that would tie down, but at the opposite, it is a kind of launch pad, the platform from which it can start away and fly, ladies and gentlemen, fly between civilizations, cultures, continents, and people. But now, let me introduce you our panelists, because the panel discussion is our next program. So please welcome from the MOL Group, the head of mobility, Tamás Cikora. Then, thank you very much. From the Hungarian Electricity Limited, the Group Technology Innovation Director from MVM, Zsolt Bertalan. The Hungarian Gas Storage Limited, the CEO, Ákos Kriston. Szabolcs Tóth, the Waberers Group Financial Director. And from our guests from the V4 countries, Petr Mervart, already you saw him on the stage, from the Czech Republic, as well as from the Slovakian Republic, Jan Weiterschütz. And representing Poland, Tomoho Umeda, the chairman of the National Chamber of Commerce, Hydrogen Technologies Committee, Hydrogen Poland. And ladies and gentlemen, please welcome the host of this panel discussion, or the CEO of our host today, the Hungarian Hydrogen Technology Association's CEO, Dr. Attila Nyikos, who's got this fantastic ringing bell to send us in.
Yes, Zoli, just one thing concerning the value chains, because we had a little discussion this morning, is that when exactly was that you bought for your wife a value chain?
A value chain. I mean, a long time ago. I mean, we are together since more than 20 years, but I try my best to make it, to do it every other year, let's say that. Thank you.
So, thank you very much. So, yes, it is personal experience. When I said my wife that I'm going to talk about the value chain, she told me that maybe you should buy me one. So, but by this getting down to business, my idea was that in this new industry, we walk our audience through this hydrogen value chain. It exists. It is different in the energy sector. It is different in the mobility sector. It's developing in time. It's developing in space. It's very different. And each of our panelists represent a stakeholder which is somehow changing course to hydrogen. It is situated hydrogen in their profit chain, but where? Where does hydrogen laying in it? Why there? Where will it move in 5 years? And because we are so numerous in this panel, and time is so limited, so I will try to focus my questions to each other's panelist specialty. So my question to MOL Group and to Mr. Cikora would be that what do you think, what are the main factors needed in Hungary and in the region to build up a working value chain in hydrogen-based mobility?
Okay, so thank you. And on one hand, I'm happy to be here. I went to high school in Zalaegerszeg, so it's the location I like a lot. So I think this question is quite complex, and of course, probably this is the question that we are trying to find the answer for in this conference as well. And a lot of things have been mentioned during the day as well. I think from my perspective, I would mention two main things. One is the subsidy side, which is quite important, and subsidy, and the infrastructure side and the vehicle side as well, because from the the infrastructure side, we also made a lot of analysis and a lot of models, like how this could work and how to place the refueling and infrastructure is not just the refueling stations, but I would focus on this. So even if there is a demand for the first refueling stations, there is like a dedicated fleet of fuel cell buses or trucks, and you install a refueling station with existing demand, even then, the subsidy need to get to a project of zero NPV is above 80%, according to our calculations, because of the high capex, and also due to the high operational and maintenance costs as well, and the low demand side, of course, because for 20 buses, it's quite expensive to put a refueling station. On the other hand, 20 buses are quite expensive, so fuel cell buses. So I think that's one side. The other side, the vehicle, because, for example, if you look at the Hungarian strategy, the Hungarian hydrogen strategy, it states that by 2030 we will have 4,800 vehicles, fuel cell vehicles, and we did some calculations. For that, the capex need to purchase these vehicles, like the total investment cost, is above 2 billion euros to buy these vehicles, and you need some subsidy in the beginning, probably to be comparable to existing technologies, to battery electric vehicles or any other technologies. So these two, I think, super important. And on the other hand, this is only the money side. On the other hand, there are a lot of practical things as well, and I don't want to be into the details of range and all these things that we have been mentioned. I would like to stress like one point that we also analyzed a bit more. As in MOL Group, we have experience in the logistic value chain to fuel stations or service stations, as we call them. For example, a comparison with transporting fossil fuels, it's usually done by trailers to the service stations. And today, a trailer to a fuel station can transport 35,000 liters of fossil fuels, and this can power, let's say, a truck for 140,000 kilometers. So one trailer can power 140,000 kilometers. And in case of hydrogen, one trailer can transport around 300 to 1,000 kilograms of hydrogen. 1,000 is like a really top of the line at the moment, as I know. And that can power 5 to 10,000 kilometers in a fuel cell truck. So the difference is 20-30 times at the moment. And this is just one example, which is like very concrete. But we need to overcome this, that if you need to supply a hydrogen refueling station with trailers, the same amount of kilometers needs to be supplied 20-30 times more trailers, which is quite a challenge. So I think subsidies and practical topics are all important.
Yes. Okay. Thank you. So how can we build up a hydrogen business case value chain in Eastern Europe, Zsolt, where there is generally, we know that not enough wind, PV availability is 10 to 15% of its technical capacity, little hydro, and cheap nuclear is used to keep electricity prices down. So what is your vision? What is your company's vision in that topic?
I think early in the morning, they have presentations about the topic whether we treat hydrogen as a third energy carrier or not. Some said that just because of the recent situation in the neighborhood in the Ukrainian war, maybe we can start talking about that this is the third energy carrier which will replace, let's say, the natural gas. But we heard lots of numbers, But let me say another one, that to replace 1 billion cubic meters of natural gas, we need more than 3 billion cubic meters of hydrogen, which might need, let's say, about 12 gigawatt of PV if we just would like to generate that amount based on PV, 12 gigawatt, which is a huge number, and also 1 gigawatt of electrolyzer capacity. And it is these are huge numbers, but also if I mention that the capex of that is 7,000 billion, that's a huge number. So I mean, we can start discussing these issues as well. But on the other hand, what I always say that it's not about building renewables just to generate renewable hydrogen on the first place. So I think that the market should be demand pulled. So if we have demand particularly for green hydrogen, then of course it makes sense to start thinking about whether there is a business case behind that or not. According to our calculations, and some says that in this room as well, that the major factor in whether this is a financially viable business case or not, I mean, to generate green hydrogen, is based on how much the renewable electricity costs. Some says that 20 euro is the limit, and if you can see now what is the market price, it's way much above that. So this is a big question, and that's why everybody is thinking about how to somehow to overcome this gap, like subsidies. The big question whether there is a reasonable amount of subsidies which are really enough to make the business case financially viable or not at all today. Yes, the capacity or the unit cost of these technologies will be cheaper and cheaper. Everybody hopes that the same, let's say, curve we'll see in 10 years than what we have seen in terms of the PVs, the panels, like 15% per year. The price is decreasing. We'll see. It might help for sure. But what I'm saying is that it should be a demand pool market and not a supply pushed.
Yes. Thank you. Akos, this morning I observed that you came with a hydrogen fuel cell car, and you are the CEO of the National Gas Storage Company. When you have invested a vast amount of money into that business, what was in your head, or what is your future plans? What is your perspective that why you choose this, and whether you have thought about the value chain that you are going to build, or how that value chain will evolve in time?
Thank you, Attila, and thank you also for the invitation. So to answer the question, basically, I think we have to first think about what our company does, and just really a little bit of introduction, just in a nutshell. So Hungarian gas storage is storing gas underground, but that doesn't mean that we have holes underground, but we have rock caverns, basically. So porous rock, like 1 or 2 kilometer deep in the ground, and we have wells, and we pump the natural gas basically into the stones, into the little like holes or porous holes, but you cannot see with your eyes, basically. So that's what we are doing. So we are very important part of the Hungarian gas system, and we have 4 storage sites as Hungarian gas storages. And one of the sites is in Kardoskút, which is in the Hungarian plain. That's the smallest site. And that site has the specialty that there is 1 or 2, let's say, separate part of the reservoir. And we thought that if we have the infrastructure and we work with really high pressures, meaning underground there's like 150 bars of pressure, we have the pipes, we have natural gas, perhaps we can use the hydrogen, and we can go into the hydrogen business using our infrastructure. And we choose the Kardoskút site to establish our project because of, as I said, there's in the future perhaps there's the possibility to store the hydrogen underground. And if I talk about storing hydrogen underground, then I'm thinking about tens of millions of cubic meters. And basically, 2 years ago, we formed the project called Aquamarine. That's a project whereby we intend to buy electrolyzers, 2 megawatt of electrolyzers, and using electricity, water, we produce hydrogen. And then the question is, what will we do with the hydrogen? We have gas-fired compressors with which we inject the gas into our storages, into the reservoirs, so we can burn the hydrogen, hopefully, in our compressors. That's one thing. The other is that we will have, let's say, temporary storage facility whereby we can fill it basically into tanks and we can sell some of this hydrogen. And last but not least, we can just inject it into the high pressure grid, so the Hungarian transmission system operators grid. So basically these are the three methods whereby we can use it. But our goal is basically, and I think we have a little bit of different view on hydrogen on the business model. So what we would like to achieve is to operate the electrolyzers only, let's say, only when there is excess electricity in the system. So basically, we would like to use the excess electricity, and we would like to get money for that. Basically, we would like to use ourselves as a balancing capacity. And last but not least, we will get hydrogen. And if we can get some money for the hydrogen, that's very good. So I think this is a bit different use. So we don't produce hydrogen because we can sell it or do something with it. But what we would like to do is we would like to be a balancing or ancillary service provider for Mavir or for the electricity trading companies. And I think in 5, 10, 15 years, my idea is to do it in large scale, because let's say in 1 year, when our facility will be running, basically in 1 hour we can produce like 400 normal cubic meters of hydrogen, which is, let's say, nothing. If you use like 2 megawatt of electricity that you can take out from the system, that's basically nothing, almost nothing. But we can test it. We can test our facility, how all the steel and how the fittings can treat hydrogen and the mixture of hydrogen and natural gas, and we can just improve our business model if we can. But my goal is that in let's say 10-15 years time, we can store a lot of hydrogen underground, and we can do, let's say, a seasonal balancing, meaning when you have a lot of excess electricity from PV, from wind, from whatever, we can store it underground and take it, let's say, out in winter and somehow give it back to the electricity system, which is at the moment, let's say it has like a maximum 30% efficiency, which is, again, not much, but I hope it will improve on the long term.
Thank you very much. I would turn to Szabolcs, and we are getting back on a track for road haulage. You represent Hungary's one of the largest, if not the largest, road haulage company. When you thought about your renewable program and hydrogen program in the truck industry, what was in your head? What was your financial director, if I'm not wrong? What was your perception of the value chain? Where would your company's this activity fit in your company's overall activity in Europe?
Thank you very much for the question. As you mentioned, I'm representing Waber Airs. That is one of the largest transportation and logistics company in Europe. We are operating more than 3,000 trucks and more than 200,000 of square meters of warehouses. So we really have a big footprint on the ecology. That means that we feel responsible for our environment, and what we what we understood that we can really make steps that have an effect on environment-friendly solutions. Starting with what Zsolt mentioned, that hydrogen has to be demand-driven technology. What I can confirm, as Waberers is connecting the infrastructure companies and the energy companies to the end clients, so the end customers, I can confirm as a logistics company representative that there is a huge demand for carbon-friendly solutions from the global and local customers of Waberers, so of logistics companies. What these companies are requiring is efficiency. So logistics is about efficiency, both financial efficiency and operational efficiency. Why we are committed to hydrogen technology? That as a company who heavily invested in the past into environmentally friendly technologies, during implementing battery based electric solutions, LNG solutions, we all experience with regards of these technologies, the different limitations, the compromises, and all of these compromises and all of these limitations are against the financial and the operational efficiency. Why we are committed again to hydrogen, that's what we experience, that at least the operational efficiency factors are all ticked to hydrogen. So what trucking or logistics is about, what is important is the range of the vehicle, the payload of the vehicle, the charging time of the vehicle, and the whole operation and the whole refueling and energy sources has to be in line with the timetable of the operation. In case of all these factors, I can tell you that hydrogen is optimal. We had a chance to visit a Swiss operation in Switzerland. There is a quite efficient operation where we could see that hydrogen is really practical. Dozens of truckers are using the technology in their daily life. They don't have to have any compromise regarding the operation. The range is quite sufficient. The payload, due to the much smaller battery in the truck, is equal to the diesel operation, and the charging time, that is in case of a battery-based electrification, can take 10 to 12 hours. In case of hydrogen, it is 5 to 7 minutes. So again, it's a big advantage. Again, regarding charging, it's not only about the time horizon of the charging of the vehicle, but can you imagine a big logistics center where we are operating 40, 50 trucks, and all of them has to be charged during the night. With battery-based operation, it is impossible to charge in one time 50 trucks. It needs so huge electricity contingent, or it's almost impossible to arrange. So one or two test vehicles we can provide to the customers, but with a huge operation, it is almost impossible. So what? Just to summarize the operational efficiency, I can tell you that hydrogen seems to be the most efficient way of trucking and transportation. That is essential for our customers and for us as a logistics company. The only missing element that we have mentioned several times during this conference is the financial efficiency. So that is the missing point, that currently the technology is extremely expensive. So once we find a solution to have economies of scale of production of fuel cell and hydrogen fueled vehicles, and once the hydrogen itself will reach a competitive level of cost, I think the whole market will switch to the only operationally efficient technology of hydrogen. So that's why we are that's why we are supporting this technology, and that's why we push with all our power this technology to widespread.
Thank you. Peter, does a seaside or sea offshore wind-based or cheap hydro-based hydrogen value chain in EU member states is different from landlocked Visegrad countries' value chain? Do you think that there is a sea-based value chain and there is an Eastern European or Middle European value chain, or I am wrong totally in that aspect?
No, I already mentioned it during my presentation because we have very specific position in regards of renewable energy. And let's say this is also my small fight with European Union because today we have that Additionality Act, which is not very, it's soft. If I say that, it's not very favorable for us, for let's say inland countries, because we really need to combine a lot of sources of energy to improve our or increase the utilization of electrolyzers. And this is not easy, because if you connect it only to solar, you have a problem. If you connect it only to wind turbines, you have again the problem. So our plan is really to combine solar, wind, and nuclear energy in one chain and produce the hydrogen based on that. Definitely, our aim is to produce low carbon hydrogen. So we are not going to produce the hydrogen which is made from natural gas or which is made from coal. And I'm talking with a lot of people because they are telling me that we should do that, that it's easy and it's cheap. But on the other hand, if we are trying to replace Russian natural gas by hydrogen, it's nonsense to do it by hydrogen made from natural gas, because you cannot replace natural gas with something which is made from the natural gas. So we have this specific situation and we need to work on that. And the only solution for me, from my point of view, is really to combine several sources of energy.
Yeah, okay. Thank you. Jan, what do you think, what will be crucial for a broader hydrogen ecosystem deployment after the first deployment phase in Central Europe, after the first pilot projects hub? What's the next step?
Yeah, we are talking about efficiency, economical, technical efficiency. So, as I mentioned in the morning, the first stage is about incentives. But after the first stage must come a really market-oriented economy in hydrogen, and we need cheap hydrogen and in big volume. So my map from the morning says everything that we need to be connected. And the most promising and the most valuable way how to connect is through the pipes. Imagine one pipe, transmission pipe with diameter 1.2 meter can hold or transport as such much energy as 6 or 8 high voltage lines across Europe. And imagine, maybe you know that Germany has a project to connect northern part of Germany with southern part with 3 lines, high voltage lines, and they are not able to finish this project because there are a lot of problems with lands, with properties, with nobody wants to build a high tower in their backyards. So I think that we should and we must use existing pipe grid to move or to transport energy in the carrier of hydrogen. So this is my answer, how we can proceed after 2030.
Yeah, okay, thank you, Orange. And talking about the period after 2030, my question to Tomoho would be that how would you describe the final landscape of hydrogen in Poland in 2050? You are a man of visions. What is your vision for that?
Okay, first of all, I think the hydrogen, we shouldn't talk about hydrogen's value chain. We should talk about value chain with hydrogen as one of the pearls in this value chain. Yes, because hydrogen, as I mentioned before, is not a final product, and it will not be a final product. The final product is the the energy that must power whatever we do our transport, our industry, our households, our cities. This is exactly what we should focus on. So what will determine the value chain and the size of installation where hydrogen is produced is not, of course, the hydrogen, but it's renewables. And why renewables, and why I'm talking all the time about off-grid systems? Because if we read Delegated Act that was published 1 week ago, we can see the criteria of certification of renewability of green hydrogen, yes, renewable hydrogen. And it says that you cannot use the existing renewable energy sources to produce hydrogen, even if you have excess energy. Why? Because that must prevent the cannibalism of energy production and hydrogen production. So you have to create dedicated renewable power sources to produce renewable hydrogen. This is very important to understand. Otherwise, if we think about excess energy in the system that we can produce hydrogen, yes, we can, but it's not going to be green one. It's not going to be renewable one, and it's not going to be certified. So companies that are using this hydrogen will not be able to prove the guarantees of origin that their clients are demanding for. Yes, this is very important to understand this. So we have to be very, very strict how we produce this hydrogen. What is the role? And the hydrogen is not the final product. Then what we have to produce together with hydrogen, for example, in our part of Europe, we are blessed with seasons. Yes, so we can think about how our heating, district heating, municipal heating systems can be decarbonized by using hydrogen. Our approach in Poland is not to use hydrogen as a fuel for heating, but let's use the operational heat of electrolysis. Let's pump it up with heat pumps, or let's use the solid oxide electrolyzers with 700 degrees Celsius of operational heat. That's absolutely enough to power up the low temperature lines in the heat grid. And in the winter, we have to collect the hydrogen from the summer. This sounds weird, but if heating contract is paying back the capex of electrolyzer, the hydrogen is a byproduct. Yes, it's very simple. If this is a byproduct, that means that it's only relates on operational cost because depreciation of capex was already paid by heating contract, and operational cost of electrolysis of hydrogen based on owned renewables is almost, let's say, very, very low. So we can use it as a storage for the winter. So the size of installation, size of renewables, and size of electrolyzer should be fit in the lowest possible production of renewables in the year, and then we have a lot of excess energy to use it for another purpose. Thank you.
Thank you very much. I'm looking at the clock and I see that we still got 5 minutes to go, which is a very rare occasion to ask questions from the, I will call you the magnificent set, if you would permit this little phrase. So the floor is open for, I think, 1 or 2 questions we can handle. And please also, when you speak up, tell that who you are and which company you represent. And please tell that from whom you would like to hear the answer to your question. So the floor is open for 1 or 2 questions, please. Yep, I give you the micro.
Thank you very much. My name is Marianic. I'm from EIT Urban Mobility. And first of all, I would like to thank the organizer for such a wonderful event. And the question I have is relating to the region and to the last thing that we heard from Mr. Hueda from Poland. So if we look at the taxonomy and we look at the energy policy in Europe, and regarding the hydrogen, and this is or any of you, what is the specific advantage and disadvantage of this region of V4 countries that we're facing?
I'm okay. Talking about the region is too hard for me because I don't know specific situation of Hungary, Slovak, and Czech Republic. So I can tell something only about Poland. Yes. So in Polish value chain, also I didn't mention about this, but after renewables we have battery energy storage and then electrolyzer that heating up the heating grid. And why I'm talking about the heating grid, because this is the fastest way how to decarbonize. But battery energy storage is very important because in Poland we have capacity market, and capacity market is paying back the capex of battery energy storage. So battery energy storage is stabilizing on daily basis profile of renewable energy, which helps a lot for electrolysis and heating. So specific regulatory conditions, that's the one thing, and seasonal conditions, because when we are talking about heating system, which is the key in Poland, we have 170 gigawatts of installed heating in Poland and only 51 gigawatts of electricity. It's very important to know that. So if we decarbonize heating in this way, that also means that we start to use the hydrogen as an energy storage and seasonal energy storage system, as well as peak source of heat when it's a minus 25, for example, and waste heat is not enough and pump heat is not enough. Then we can use this hydrogen hydrogen engines, hydrogen combustors, or I don't know, solid oxide fuel cells, for example. So this seasonal structure really helps when you start from the heating, and the heating business is the key. If we want to establish hydrogen only with renewables because we have renewables, so we have idea, let's make the hydrogen. No, it's not gonna work. Never. In Poland, I don't know, maybe here in Hungary will be better with the weather. I don't know. Thank you.
Okay. Thank you very much. We got still 1.5 minutes for us for a second. A very, very quick question, maybe a yes or no question. If there are no more questions, then I will thank our panelists for the preparation for the work that they prepared for this event. And I would like also to thank our audience for the question. Thank you very much, gentlemen. See you at our next conference.
Thank you very much for all the panelists, and thank you very much for Attila for the professional hosting and moderation of this panel discussion. Thank you very much. And now we will continue with our some of other keynote speakers, and we will focus on the mobility sector, because they are tech providers, so representative of great tech providers, and we invited very knowledgeable people to tell us some novelties from the present and from maybe the future technology. And as far as I know, our guest from the Siemens Mobility has to catch a plane, so as a second speaker we will change a bit the order. Let me start with Mr. Zsolt Benedek from Linde, and then a few words on the expert views on clean hydrogen opportunities, and then we will continue with our guest from the Siemens Mobility, if it's okay for you. But now, ladies and gentlemen, please welcome Mr. Zsolt Benedek from Linde.
Thank you very much for the words, and welcome everybody here. Ladies and gentlemen, my name is Zsolt Benedek, and I'm representing a service provider company. Well, I will tell you later what we are doing here. But let me start first with a potentially bit provocative sentence, one through, and please just digest it in the very beginning, and I will come back to this point some minutes later. So what I want to say here, that hydrogen mobility, which is our major topic today, cannot exist without a sustainable hydrogen ecosystem. So basically, the sentence was very well explained just a few seconds or few minutes ago by all the colleagues, basically, who was talking about sustainability technical, financial, economical sustainability of hydrogen systems. But let's again come back to this a little bit later. First, just a few words about Linde's, my company's engagement in the field of hydrogen. Without going to the very deep details, we are really active, very much active on basically all field or all elements of the value chain. So from the production, different kind of, we are the biggest, let's say, gray hydrogen producers in the country, in the region. These are steam reforming technology from natural gas in an industrial range. We are also building electrolyzers, or affiliate company is producing these electrolyzers. Also, we are also active in carbon capture, so CO2 capture from different sources. Also, well, I mean, lot of experience we have in transportation, storage, and material usage of compatible with hydrogen, and also active and more active on the field of mobility or fueling, refueling. So these topics are coming more and more into the focus of our activity, which is not our field, is the end using. So that's clearly something which we are not having the so much expertise or so much experience as in the other areas. But this is also something we are focusing on. So that's something about my background or my company's background. So you can see that the perspective where we see this whole potential or in the hydrogen business is something which is not only one focus point, but quite many. So that's why I would like to highlight a bit how we, as you can say, technology provider, main producer, see the future or the close future of green and clean hydrogen and the whole the business. So first of all, and this is the utmost important thing that we have to state in the very beginning, that hydrogen is not the ultimate goal. It's not the final target. It's a tool. It's a very valuable, very important tool to reach the target. What is the decrease of the CO2 emission in the globe? So that's yes, I'm confident that hydrogen is a most contributor for that, to reaching of that goal, but not the target. So where can we decrease the CO2 emission? Obviously, when the CO2 is rising. Where the CO2 is rising mainly, this is typically the ammonia production, the refineries, the fertilizer production, steel mills, importantly, and of course the chemical industry, the plastic production, the synthetic material production. Shall we start with putting everywhere green hydrogen, or shall we start with something which we can decrease the CO2 emission? I think it's clear that if it's possible, if it makes viable, then the first target should be to try to decrease the CO2 as much as possible, and then as a second step or a following action, we can continue with the clean hydrogen introduction. How does it look, or what is the perspective of? There is a lot of debates whether the sourcing of this green hydrogen or clean hydrogen sources, namely the electrolyzers, is should be centralized or decentralized. Or commercial or business perspective is certainly that we need to integrate it. We need to try to condense it in close to the major consumers. in order to lower the capex and the opex, or the specific cost of such a plant. So I think this is quite obvious things if you can compress it into or condense it to some few locations that you can reach a lower cost level. This is, of course, the question of the debate between the hydrogen Wally idea or Wally's idea versus the isolated small size electrolyzers. What I also wanted to state that the hydrogen usage of hydrogen mobility alone, in its own, cannot maintain the base load even for that big electrolyzer sources. So alone, mobility will not solve the problem. That's for sure. So this is a side action should be to the other already mentioned directions. I have a slightly different view on transport visions. So our view was in that for a shorter distances from this centralized electrolyzers or centralized green hydrogen sources, for short distances, the pipeline is a good idea and a good way. For medium distances, the classical trailer or pressurized gas trailers is the best and most effective way of transport, and only for long distances, which is not the case in all countries. In the Visegrad countries, I believe, the liquefied hydrogen is the solution. About mobility, business view on mobility, or at least our view on mobility, is that the main focus should not be the personal vehicles. This is something which we consider as a secondary step. Main focus should be on commercial vehicles, heavy machinery, like trucks, buses, trains, whatever you can call, forklifts, importantly, and basically around a certain transport corridors or cities, in cities, or industry parks services. So this is the typical best usage of the mobility. What are the main challenges? What we do have, or what we are facing into? Obviously, I mean, clearly everyone is interested on producing hydrogen, but basically no one has a real off-taker idea. So if anyone can produce hydrogen, green hydrogen even, but what to do with this green hydrogen later on? This is even more difficult question, and this question is never or very rarely answered by those ones who are ready to produce big volumes of hydrogen. So that's a challenge. And the other challenge, as we heard already several times today, that the availability of the renewables energy, which is also not an obvious thing, that in all countries we are so rich on those. Let's look at it from the commercial sustainability perspective. I just made a very simple comparison without having real prices or numbers, but just a ratio about between the steam reforming technology, so what we call typically is the gray or eventually blue. If it's recycled CO2, if it's recycled, then we call it blue, but it's still considered as natural gas-based hydrogen production, which is the current industrial big size of hydrogen is produced from. So here the main contributors of the cost, or basically price, is the main one is obviously the natural gas price, and more and more the carbon tax. So what's what will be the cost, or what is the actual cost of CO2 emission, and what will be the cost of CO2 emission in the coming years? Versus we have the electrolyzers, the hydrogen produced from electrolyzers, what we depending on which energy we are using, we can call it green or yellow. The main contributors of the cost price is the electrical power price. Presently, you can see here that the difference is quite big. I mean, the electrolyzer's hydrogen is 3 times more expensive than the conventional natural gas-based hydrogen. The only thing which keeps it in balance is currently the subsidy. So which we can agree that it will be a forever given thing. So I believe that the whole business case should stand in its own feet. It should be self-sustaining and should bring a positive NPV. Otherwise, it will not be a long run business. Despite of the I'm running out of time. Sorry. Despite of the all these difficulties and all these challenges, we in the Linde Group, we are convinced that this is we can. I mean, together with the Visegrad countries, we can basically come over all these problems or challenges, and we are ready. And I'm full confidence on. I have full confidence on that we are ready to step further on the way of the green and clean hydrogen way. As you can see, we have several solutions already, and all these solutions are under continuous development. So it is bringing more and more benefit for all of us, which we are ready to continue. And last but not least, talking about mobility, I have to mention that still we have the one and first and still the only one hydrogen fueling station in Budapest, in our headquarters, which is still not a commercial fueling station, but again the only 350 and 70 bar fueling station operated so far in Hungary. And with this, I thank you for your attention.
We thank you for this presentation to Zsolt Benedek. Thank you very much. I mean, this filling station played a crucial role during a demo run, ladies and gentlemen. We had actually in the Hungarian Budapest public transport a hydrogen-powered bus for, let's say, 3 weeks, and the public received it very, very positively. So we already had some experiments on this one. So let us continue with the representative of the Siemens Mobility, ladies and gentlemen. A few words about the sustainable and emission-free railway mobility by hydrogen, the Miro Plus H. Ladies and gentlemen, please welcome Jochen Steinbauer.
So, thank you for the invitation. It's a pleasure to talk to you briefly about this latest product of Siemens Mobility. It's a nice and fancy train. We call it Miro Plus H. The H is for the hydrogen, of course. But let us put the focus on 3 issues when we talk about hydrogen. So the first aspect is what we need to mention. It was already raised this morning and the presentations before. What is more important, demand or consumption? Demand or production? So what comes first, chicken and egg? This is the main principal problem. And therefore, these trains that require a lot of hydrogen and consume a lot of hydrogen, they provide a significant advantage. Because we know very well what this train at which time, at which day consumes. So the consumption is absolutely predictable. And this is so important for getting this hydrogen economy started. So we know the consumption, and the providers like Linde and the others can exactly deliver the hydrogen we require. So this gets this complete business started. So this is the first aspect. The second aspect, okay, it's not a high sophisticated technology to design and construct such a hydrogen train. But the today's future and tomorrow's future requires more than a nice looking hydrogen train. It requires innovations, and it requires that we cover the aspects of tomorrow. So what are the aspects of tomorrow? If we look to Germany, there's the €9 ticket, so you can take the railway mobility, urban and regional traffic for €9 per month. This is amazing. It's really amazing. So, but the situation is as follows. The trains are overcrowded, and it requires more trains. It requires shorter headways, and it requires trains that are more powerful, that can better accelerate and keep the shorter time schedules. So it's about providing a train, a hydrogen train, of course, that provides value add even to this situation. Meaning more powerful trains, more acceleration, a better speed. And this is exactly what we did with the Mireo Plus H. And the third aspect is there's, of course, the rumor hydrogen trains or hydrogen technology is a very complex technology. It's innovative, but it's complex. Complexity means it's costly. So, of course, this is a rumor, because when we only look to the capex, it is definitely like the situation that the hydrogen trains are more costly than a diesel train. But it's not the end of the story. We have to consider the whole lifetime of the train, of example, 30 years. And when you remember your diesel car, you go to service one time a year, and you go for 10, 20,000 kilometers a year. Diesel train takes the 20,000 kilometers per month. So the maintenance effort for these moving parts in your diesel engines are enormous. And when we look to the hydrogen train, there are no moving parts. So the only bottleneck is the hydrogen fuel cell or the stacks. So when do we have to exchange the stacks? And of course the battery. And that's the reason why we as Siemens Mobility, and I skip to the next slide, put this Mireo Plus H onto the stage. And we put the emphasis exactly on reducing the life cycle costs, not only the capex, but also the life cycle costs. And this is important. And that's the reason why Siemens Mobility spent $10 million in developing a complete next generation of fuel cell systems from together with our Canadian company and partner Ballard. So reducing the life cycle cost means extending the exchange intervals of these stacks. We're also using LTO technology, which is a very robust and powerful technology for the batteries. And of course, we introduced silicon carbide technology. We introduced a new smart energy management system so that we keep the operational costs as well as the maintenance costs as low as possible. But of course, it's still a complex but innovative technology, and the capex are of course higher than for a diesel train. But at the end of the day, the total cost of ownership are today already, when considering the hydrogen price of about €5 per kilogram, at the same level as for a diesel train. So there's absolutely no reason anymore to buy diesel trains and to get them into operation. But what we need to start even this economy, this hydrogen economy, also on the railway mobility, is to introduce pilot projects. And this is a pilot project we do together with the Deutsche Bahn in Germany and the German Ministry of Transport. The German Ministry of Transport is spending €15 million for this dedicated project. And it's about not only the train and the service, as we from Siemens Mobility do, but it's about, and this is the job from Deutsche Bahn, producing the green hydrogen out of the green power running already through the overhead catenary system. So you can imagine there are great junctions, and from these great junctions, there are branch lines to the suburban regions that are not electrified. But at these main junctions, the main lines are electrified. And almost, I think 60% of the power is already green in Germany, running through the overhead catenary system. So we can easily produce green hydrogen out of the power running through the overhead catenary system. And this is a new concept, and I like it very much. So it's a mobile hydrogen production system, a hydrogen storage system, and of course the dispenser system that can be introduced there. And this is a pilot project, and this will definitely be a push to the railway mobility. But it's not the only project we as Siemens Mobility did. So we started this business with hydrogen trains already in 2017, did some testing. So when we started in 2017, we could not even spell the word fuel cell or hydrogen. So we had no idea about this. So we had to start and playing around with the fuel cell, doing the testing, and we optimized the interaction of the different subsystems. And we entered 2020 the project with Deutsche Bahn. And when we did it, and this will be in the southern part of Germany, then the Minister of Bavaria came to us and told us, oh, you cannot do this. So without considering Bavaria. So we had to do the same more or less in Bavaria. And recently we were awarded for the first project. So this business is already getting started in Germany. And we are really proud of this sequence of success stories. And this is even into the last word. There is no excuse for doing the same in other countries. It's about to introduce pilot projects that get this business started. The trains are now available. They are reality. We have presented the first train from Siemens Mobility some 4 weeks ago. And you will also see this nice train at the InnoTrans exhibition in Berlin in September. And we are really happy, and we would be the partner for even the first project in all these countries we are talking about, with the first projects, with the first initiatives to start this hydrogen economy on the railway mobility sector. So we are ready. It's about us to introduce these trains. So, and finally, the train is, I like it very much because it has a fancy design, but the technology is, of course, really, really innovative. And we did not do just focusing on using simple technology, which is available, but we just advanced this technology and put a lot of innovations in this technology, in this train. And that's the reason why I think this is a very, very future-oriented train. So thank you very much for your attention, and I hope we could just tease in this business for railway mobility and make you curious on just starting even the initiatives in your dedicated country. Thank you very much.
Jochen, thank you very much. We can't wait to be a passenger on one of your fantastic trains. Beautiful skin, but what's under the skin, it's even more fascinating and amazing. Thank you very much. I know exactly some very important guys from the world of car racing are a big fan of public transport, like the 2016 Formula One World Champion Nico Rosberg uses the train very, very frequently, or Sebastian Vettel also uses train or buses. So these kind of solutions. And now we continue with another topic on mobility, ladies and gentlemen, because there is the AVL company who develops a lot of smart and very interesting solutions in the mobility sector. But what about the hydrogen? Are they developing some solutions, technological solutions with hydrogen technology? We will have the answer in the next few minutes. Ladies and gentlemen, please welcome from the AVL Hungary, Adam Szigeti.
So thank you very much for the floor, and a warm welcome to everyone. We're at home with AVL here at AVL ZalaZone, but I will get into that in a minute. So first of all, just a little bit about AVL. AVL was founded in 1984, so a long time ago. Our headquarters is in Graz, Austria. We have currently 12,000 employees globally at 46 affiliates around the world. And you'd be glad to know that Hungary is our number 2 location globally. We have 4 sites in Hungary, one of them being ZalaZone. So here AVL is renting the ZalaZone proving ground and operating it. But also, if you look to the other side, you can see our brand new AVL Hungary. Oh, thank you. Our brand new AVL Hungary building, which is 100% owned by AVL Hungary. And there we provide you with all kinds of engineering services related to the testing ground. We are also in Budapest at the Budapest Science Park next to the Technical University, and also we have a new campus in Érd, just outside of Budapest. We're planning to build up 1,000 people there, so it's a very strong new campus with all the new technologies that are coming along, so batteries and hydrogen. And also, I'm going to show you one slide at the end in Kecskemét. That's our new tech center that's focusing only on hydrogen. So all the services and products I'm going to show you are accessible also in Hungary via our Kecskemét tech center. So we are basically involved in all sorts of transportation development. On the left-hand side, you can see basically all the types of vehicles we are working with, and you'll be glad to know that we have a hydrogen solution for all these types of vehicles. Also, again, if you look at Hungary, AVL is quite big, so we have powertrain engineering development platforms. That's basically the test benches AVL is very famous about, and then AST simulation and testing. AVL Hungary is 90% powertrain engineering, so those would be the services again you can reach here. But also about AVL Hungary, we're very much part of not just the Hungarian innovation ecosystem, but also part of very seriously of the global AVL innovation system. We filed, for example, last year, almost 20 patents here in Hungary. So with that, we are, I think, number 3 or number 2 from all the companies within Hungary. So basically, as AVL Global, we do everything when it comes to mobility. When it comes to AVL Hungary, we focus much more on the powertrain engineering. So AVL, as you can tell, was founded as an engineering company that's mainly focusing on the internal combustion engine. And due to the technological changes that are coming along, AVL is also facing a huge technological change. So we are very much going into the new technologies, meaning hydrogen and batteries. So these are the 2 options we are currently working on. One of them is the AVL hydrogen internal combustion engine. This is the solution I'm going to talk mostly about today, but you'll be glad to know, of course, we are working with our own fuel cell systems and technologies. We recently purchased a fuel cell company in Canada, in Vancouver, so we also have our own stack now, and that's what we are offering with all the engineering services. Okay, so if you look at this slide, just a little bit of a background to why we are doing this and why there's a huge demand on the market. You also had on a video a DG, I think DG Mobility or DG Energy from the European Commission. And she said, that was also surprising to me, that by 2035, in the European Union, CO2 must be reduced to 90% when it comes to mobility. I have another basically a graph that shows you greenhouse gases at the bottom. You can also see the US targets there, but when it comes to greenhouse gases altogether, the target is to reduce them with 30% by 2030. So it's very close. It's only 8 years that are left to reach this target. And I think the European Commission is pushing very hard, both companies and countries, to be able to reach this target. So what are the solutions we're working on? First of all, so this is our current status on the AVL hydrogen engine. We have a multi-point injection engine at the moment. You can see the efficiency there. It's all working with compressed hydrogen at the moment. Also, there is a low pressure direct injection engine available with a little bit better efficiency. And of course, there's the high pressure direct injection option as well. So this is our current status. We are developing all these solutions further. And of course, the goal is, as you can see on the right-hand side, to go into liquefied hydrogen options or solutions. It's still coming up, but I think we are on a very good track. So what are the advantages of the hydrogen internal combustion engine? First of all, you carry over all the engine-based components, the powertrain, and the whole vehicle architecture. Also, from this, you can tell that time to market is very low, so you don't need big changes in the car in order to make it run on hydrogen. That's also helping reaching the European targets. Also, durability and robustness when it comes to heavy duty. And of course, the TCO, the total cost of ownership, comes down to a very low number when you adapt your car from a normal ICE to a hydrogen ICE. So yeah, this is also to our current status. So basically, to summarize it, the AVL approach is to keep everything that we can from a normal car in order to reduce the cost of ownership. And basically, with the current developments, we are reaching post Euro 6 emission rates or Euro 7 emission rates. And what we are exhibiting today, you have a virtual reality glass just here in the corner, and you can see into the world's first heavy duty multiple injection engine. I have a colleague there who can show you that. That's an AVL solution that should be on the market by September. So, and then this is our fuel cell portfolio. So going into the other solution, all the AVL products and services we are offering in fuel cell. I'm not going to go into detail here. Yes, but you can look around, and I'll also have colleagues next to the vehicles. We have outside a Volkswagen Passat that's been changed into a fuel cell vehicle, so you can go and have a look. So these are the two almost on the market solutions we are offering at the moment. And if you need any advice or you want to talk to someone, engineering services related to hydrogen, then of course our Kecskemét center is being built up right now, and you can turn to those guys. This is going to be two things, both a development center and also a test center, and the whole AVL portfolio would be provided through this Kecskemét center to all the Hungarian companies that are interested. So this is it, very briefly, and thank you very much.
We thank you. for the presentation. What kind of developments are ongoing at the AVL Hungary? Thank you very much. I just recognized Michael Schumacher's Ferrari on the picture regarding the logos and the the design of the car and the helmet. It was the 7-time Formula One world champion, and AVL is working very, very closely and in close cooperation with the Formula One teams. I mean, in the interpretation of the rules and regulations, I mean, they are offering some developments for almost every Formula One team. And to be honest with you, it was a great podcast series produced by the AVL, the Graz headquarters, about the latest technologies in car racing and in Formula One especially. I was a big fan of this podcast. I hope they will continue this one. And last but not least, ladies and gentlemen, let's hear a few words about the hydrogen motor train developed by the Alstom. Ladies and gentlemen, please welcome Zoltán Galac.
Thank you very much. Welcome, and it's a very good opportunity to be here. I would like to show you the first hydrogen-powered passenger train which started the operation first in the world. This is the Coradia E-Lint. I would like to show you a very recent video what was prepared more or less 1 month ago in Czech Republic and Slovakia, when this train was demonstrated to the public and to the professional stakeholders. First, I would like to introduce you what is the past and what is the present. Still on the right side, you can see. What is the future? Alstom is very engaged himself in order to be aligned with the politicians' regulations in order to reach the zero emissions. Alstom is the main target is for them is to develop a train for the non-electrified lines. This is the zero emission trains. There are two different possibilities. The first is the so-called battery power car, which is more or less an electric multiply unit, which is equipped with heavy batteries in order to make more or less 80, 100, 120 kilometers independently from the catenary. The other solution is the hydrogen train, which has a very big difference compared to the BMU, that the range is up to 1,000 kilometers. And the performance of these trains is totally equivalent with the present operating diesel trains. There is no any obstacle. The fueling station, the fueling operation can be done 15, 20, 25 minutes, more or less the same time as the diesel trains. The FCMU technology is we are placing 2 fuel tanks on the top of the trains and 2 fuel cell composition in the top of the trains. And of course, there is a battery which has 2 main objectives. One is in order to get the recuperation. The other is in order to boost the traction if needed, and the fuel cell is not enough power to boost the train. So there is a traction inverter and the traction motor. All of the equipment is out of the passenger compartment. So this is the Coradio E-Lint. This is based on a successful Coradio Lint 54, which was a DMU, diesel multiply unit, and this was designed for the Central European countries. No technical components in the passenger area, as I mentioned, and 0 local emissions. And what is very, very important, the reduced noise level. This was the most important, one of the most important factor what we could realize that the clients in the different test operation enjoyed very, very heavily. Of course, the trains are up-to-date TSI compliant and easy access for the people, PRM people. This train is 54 meters long and more or less 150 seats is on the board. There are 2 different floor possibilities, 620 and 810 millimeters, and the maximum speed as the other diesel trains is 140 kilometers per hour. And the range is 1,000 kilometers. More or less 130 kilogram hydrogen has each car, so altogether 260 kilogram hydrogen on the train. This, as I mentioned you, this is the first hydrogen operated passenger trains in the world. It was developed in 2018 and it was presented in the exhibition in September 2018 in the rail exhibition, and after 18 months trial period started with 2 trains, also with passenger commercial services. They were running more or less in the 18 months 180,000 kilometers, and during this period they could get the homologation authorization by EBA. After started different other countries, the different tests. Netherlands, it was 2 weeks, it was only a test campaign. Austria, it was 3 months, 2020, with passenger commercial service. This train was operating in the same line when other diesel trains was operated. The big difference between Netherlands and Austria is that in Austria, of course, there is a lot of mountains, and the trains could reach really the timetable of the other. This was a very successful test period, 3 months with passengers. After we sent the train to Poland, there was a test campaign in Krakow in 2021, and after Sweden, which was in operation and presentation. France arrived in 2021, arrived in France, and all of these countries, this was the first hydrogen train trial runs in the countries. Germany again, 8 months, and just recently, May 2022, in Czech Republic and Slovakia, when they were running 1,250 kilometers in 8 days, more than 20 cities. So we can state really that Alstom Coradia E-Lint hydrogen train has already 4 years experience from 2018 till 2022, different operations, 7 different countries, and the train is homologated in 2018. So this train is available. If we are speaking a little bit about the infrastructure, of course, Alstom is not dealing with the infrastructure, but for the different test runs, they use this container for refueling the trains case by case. But for final operation, really we need refueling stations, which is a big investment. And a few minutes ago, other partners was presented it. Alstom has different partners in different companies. In Germany, we are dealing with Linde or other companies. In Hungary, we signed a Minutes of Understanding with MOL, Hungarian Oil and Gas Public Company, in order to make a partnership, in order to accelerate the infrastructure ready for Hungary for railway operation. But of course, this infrastructure can be operated. This infrastructure can be performed not only rails but other buses or trucks or others. So the benefit of these fuel cell technology trains, and I fully agree with the other spokesman, that no need in the future to buy diesel trains, because you can see that one train has more or less 700 tons CO2 reduction per year. And if we are speaking about another number of trains, you can see that 22,000 of tons can be in case of 30 trains. We have already several projects. In Germany, we have 2 contracts, and one is in the LMVJ, customer name is LMVJ, 14 Coradia Lint was sold, and the start of operation is very soon, 2022. If I know well, more or less August, September, they will start the operation. What is very important here that the clients here, they are buying not only trains, but they are buying services. They are buying a 30 years maintenance and a 30 years hydrogen supply. The maintenance, of course, Alstom is doing by themselves, but for the hydrogen supply, Alstom is making different agreement with hydrogen suppliers. The other project which is running already is the RMV. The client is RMV. When 27 Coradia E-Lint was sold, the start of operation also 2022 and 23, and here also there is 25 years maintenance. This maintenance and hydrogen supply contract really a guarantee for the client that the train will operate for the lifetime of the train. Alstom has another project in Italy, which is a Coradia Stream. Coradia Stream is normally an electric multiply unit, 4 cars, but here on the middle there is a hydrogen power card, which is containing the hydrogen storage and contain the fuel cells. In this case, the capacity of this train can be 240-260 seats, and the maximum speed, of course, 140 km per hour. This project is sold 6 trains in Italy and 8 optional trains, and more or less this will be delivered also in 2023. So very soon we can see that more or less 40-45 trains, hydrogen-operated trains, will start the operation in the neighboring countries. Thank you very much.
Thank you very much, and we can't wait to travel on these trains. Thank you very much, Zoltan. A few years ago, I was lucky enough to visit the headquarters of the Alstom in Paris, and it was really a take a look into the future. It was a huge and beautiful presentation about the vision of the Alstom, and I'm lucky enough to be a member of that team to visit the Alstom Paris headquarters. Thank you very much, Zoltan. Now we will have a short break, and then let's say 10 minutes, and then we will continue with 2 other very interesting keynote speeches. How and what play can the nuclear plants can roll in this hydrogen industry? And it will be, I think, very, very interesting. So we'll see you in about 10 minutes after the short interval. Thank you.